All right, we're going live again with some morning stream, coffee for coders. Coffee with coders, I think I'm calling it. It doesn't matter. I think today we're going to go through and write some Cloudformation for the architecture we came up with, the Serverless Record Processor. Yeah, it's going to be just a chill day writing some code. So we'll hop over here into my Cloud9 development environment. I like using this because it gives me access to all the power I might need of the cloud without having to mess with my local machine. All right, so actually let's look at our architecture diagram. We have, a lot of pieces here, and how you assemble this thing is kind of important. I generally start with the data store elements, the things that will persist data, so like the buckets, queues, Dynamo table obviously is going to be a major piece here. We get a lot of functionality from that. So I think that's probably where we're going to start today. Dynamo tables can be kind of a bugger to write in Cloudformation because there are so many options and so many pitfalls when working with tables. I think that's where we'll start today. I'm just trying to think how we'll split this up, because building too large of templates means that you're touching a lot of resources every time you make changes to it, and that can be really, really annoying. A little light here. So I think we're gonna work. Let's do this back half here. Why it doesn't capture my mouse? I'm gonna figure that out. So the Dynamo table, the stream, and the reporting bucket. Let's probably work on that part first. So here we are in our Git repo. Actually, I think I'm in a branch right now. Yeah, I'm in the add image branch. I did that because I added this image to our README. So this is in the README now. So let's get back into master branch. Make sure we're current. Cool. So I usually start with adding a folder for infrastructure. And we are going to do the what are we going to call this? We'll call this the table, processing table. I don't know. And you'll notice I went with YAML, even though in the past I've had a lot of issues with YAML. I'm going to do that just because it seems to be the way most people are going with their templating. So we'll work with that so that we can see how, if there are any issues we have to work through, we can deal with them on this in this video series. So then, yeah, I usually go and just grab a basic Cloudformation template example, something like this. And then I get rid of the resources because that's not what we're going to use. And then we go over and find the Dynamo DB Cloudformation definition. You can copy the JSON or the YAML depending what you're working with. So we're doing YAML. Give you these nice little copy buttons. I copy the whole thing. I take the full definition here, copy that out, and I do that for a couple reasons. One, so I don't forget anything, rather than trying to build these things up. Make sure our indentation is right. So we're going to name this process records. Oh, this is gross. Okay. See, these are spaces right now. And we're not going to have a big argument about tabs versus spaces right now. I don't have the energy for it. Oh. This is fun. We'll just sit here and watch me format text. I know everybody really likes that. So why do I copy the whole thing? It does two things. So I don't forget anything. There's nothing worse than forgetting to put properties on your Cloudformation resources and then trying to deploy and waiting the 10 or 15 minutes it takes for Cloudformation to decide that you didn't do it right. And two, by seeing all of the options here, it helps me understand like how Amazon approaches, or how AWS expects these resources to be used. There are a lot of things in here that they're clues. They're things that you might not realize that a resource can do, or each one of these things can lead you down a path that you didn't expect a resource to be able to, like when new features come out. So I like to put the whole thing in here, and then I just go line by line and figure out if I need it or not, because not all of these things are required. I always like to put my table name at the top. So we're going to just name this the processed records. Billing mode is an important thing. Dynamo tables have two modes right now. One is on demand. I believe it's called per request _ and then you do provision capacity. We're going to do per request during the prototyping phase, so we don't have to worry about scale. It is more expensive, but there are times where you're troubleshooting something and you don't realize that you've run out of capacity on your Dynamo table, or there are moments that you'll spend time troubleshooting things that you shouldn't be worrying about yet. So I usually go with this on-demand billing mode in the beginning, and then once I get data flowing through it, then I'll come back and I will write I'll switch it over to provision capacity, and then I'll write auto scaling on the table. The reason I'm not doing that now is because it's really, really long, and if this were a professional environment, I'd probably have somebody out there asking me to show that this is getting done. So this would allow me to get kind of a prototype out the door pretty quickly. And then the nice thing about the Amazon stocks is you can just click through these things and they'll tell you all the options. Ooh, okay, so it's pay per request. I screwed it up. There are a couple things about Dynamo that are really important to know, like regarding the indexes. There are certain indexes that can only be created and not updated. So I think some of the local secondary, let's check that out. Yeah, so Dynamo has a really interesting. It's a NoSQL database, so it has the access patterns are limited to a key and a range, or a hash key and a range key, and that's pretty much it. So you really have to understand how you're going to access this data. Like how does your function, which important pieces of data or properties of that data will be used to select it. And you need to figure that out ahead of time, or be willing to iterate through your table, delete your table, start over. And you'll find, when you're scrolling through all of these properties in the table, or on the Cloudformation documentation, where you see these things like update requires replacement, that means you have to delete the resource and recreate it. So, like your schema, this is why it's important to understand your schema ahead of time. Some of these things can roll through. Like here you can add some backups to your table with no interruption of service. You can change your provision throughput without interruption. I love that encryption has some interruptions. Wonder if they actually call it out, or we'll have to just... No, they're not going to give us any details. So you should expect, if you're updating your table, encryption or something like that to be interrupted. I guess that makes sense. You're changing the way that the data is written to persistent storage in the back end, so you should expect those things. So I think the important thing, so the indexes on your secondary indexes in your Dynamo table will be kind of different slices of the data, different ways to view it. I don't know that we're going to have any of those yet, so I'm going to remove those, but remember that they are an option, and then if we need to, we'll come back and add those, probably delete the table and start over. If we have actual data in there, we probably won't delete it. We'll probably deploy a parallel one and then migrate. So the really important things to figure out here are the key schema and these attribute definitions. I think that will be the minimum to get this thing out the door. I don't think I want to deal with backups right away, but should definitely be you should definitely think about this when you're developing this stuff. So here's the provision throughput. So this defines your read and write capacity. Like I said, after we get this thing rolling and we know that the data is flowing through the table to the processor, the processor into the bucket, then we'll come back and we'll add provision capacity rather than, or provision throughput rather than using the on-demand billing mode to save a lot more money. And we are going to use this stream specification because we are going to have we're going to have a processor that is triggered based on events on this table. So that we'll need to define this as well. What else we got here? Tags. Always apply tags to your resources. Even if you don't think you'll need them, even if it's just a toy, always do tags. And that helps you understand how much things cost. It helps you understand like where they came from, who deployed them. There's a whole tagging. Tagging can actually be pretty involved in a large organization. So I think one of the very most important things you can do in the beginning of a cloud migration project is to define some kind of tagging strategy, and then be super aggressive in getting them applied. Don't let people deploy things without tags. Even if it's a prototype, even if it's somebody just playing around, always do your tags. We're doing Cloudformation. So Cloudformation will, when you deploy Cloudformation, you pass tags in the deploy command, and then that will pass those tags down to the resources. For the most part, there are still some that don't. This has been a long, kind of slow rollout from AWS's side. So we may not actually need tags here in the definition. We may be able to use the stacks parent tags and let them flow down. So I think we'll just leave that. And then your TTL. It's really important in the data management of Dynamo to understand how long your records will last. And I say this from past experience where people would just write everything into a table and then they say, oh, we'll figure it out later. And then not figuring it out for 4 or 5 years. Probably not that long, but I guess I've been working with it for 4 years. So just writing data, pretty soon this thing is gigs and gigs. And then you have to go through and figure out which records do we actually need to keep? If you had thought about that ahead of time, you could have applied the TTL, and then in your application code where you're writing the Dynamo record, you also put the TTL in there. And I think it's in Unix timestamp. We'll have to look at that. And luckily we can do that right from here. This is why I like working from Cloudformation, because you can just kind of explore all of these properties. So I'm going to do a TTL right away. Because, why? Because two things. My NFR is here. I don't like to pay when my system isn't doing anything, and I have a $2 sign budget. That's based on the restaurant scale. When you look them up on Google or whatever, they tell you how expensive is it. Well, we only have $2 signs to spend here, so we have to be good stewards of our budget. So that is things like making sure you clean your data up. Make sure you think about how this works. So I'm trying to decide if we have it enabled by default or not. I think we will. And then, so this will be enabled. This will go through and just cull records that have expired. and we'll make sure that we can tune that in our application code. We can tune how long we want these records to stick around by just changing what we write to the table. What are we going to call our? I don't know, I always just do like TTL or something. We don't need to be super fancy here. Stream specification is how we define what the stream record data will define what that looks like. So when you have a stream on a table, it will push that event down to whatever you have downstream. So it's, you know, a Lambda or SNS topic, and we control what that looks like here with the stream view type. So you can configure it multiple ways. So you can have just the keys. So if you just want like an ID or, you know, one of the identifying, you know, records, this would be like if you had some kind of notification system where, you know, somebody changed table data, and then you just had some process downstream that says, you know, oh, a customer, you know, maybe it's a customer ID that flows through the stream to your processor, and then this thing will kick off some other process that tells you a customer, you know, wrote data. So maybe they placed an order, or maybe they uploaded some data for processing. Like, who knows? Like, there's many ways you could trigger this, but if you just needed the keys that changed rather than the whole record, and then we have the whole new record, you can look at the old record, or you can do both. And then that would be if you wanted to do like differences, if you wanted to capture the differential between the old and the new record. So if you're doing some kind of downstream change system, or maybe it's an audit, maybe an audit trail, you can use these things to capture and log what happened in that system. So we only care about the new record because we're not going to be, I'll copy this one. We're not going to be changing records once they're written. Once they're written, they stay. And we're doing that because bothered me. We're not going to go back and modify records once they're processed in this system. There's not going to be any, you know, these records will be immutable at this point. I'm trying to think while talking. Not good at it yet. So we don't have, I don't think we actually know what our data looks like. I think I have to just fake it. I have to create it. Which is okay. You know, once we know what it looks like, we can modify it afterwards. So let's figure out what our keys are. So I think there will be let's see. So we'll do a list of keys. Dynamo table, you can only have these two keys. This, you know, designing a good key schema is absolutely imperative when working with Dynamo. This is what gives it its speed and its scale, is the constraints around how you define these things. So a good it's a good idea to come up with this in the beginning when you're just thinking about your system and how it'll access data that'll come out of this thing. So I think we'll do a hash key. I don't know, what should we call it? Like a customer. I don't know. I'm trying to remember the conversation I had with my friend about this. He was kind of vague on the details of the actual data. So let's say this is a customer ID. And this will be our hash, and then we will have a date time, which will be range. Yeah, so your key schema is a list, signified by this dash here. A list of these properties. I think that oh, I forgot attribute definitions. I don't know if I think we need to also define the keys. Yep. Oh, so we need to actually define what data types they are. Whoops, there we go. So the data types we have are pretty simple. String or a number, or type binary. So we have customer ID is probably going to be a string question mark, right? It's an S. And then the date time will probably be a number. That's a good question. That'll probably be a string, actually. I don't want to store it as Unix timestamp. I want to store it as an actual formatted date string. Okie doke. We're going to pull tags out from right now from this level and save. Clean it up a little bit. Always put descriptions on your tables. I've seen so many places where people leave the description fields empty, and that kind of drives me crazy because it's really useful data for people who don't understand the environment really well. One thing I started doing in the past was actually taking the URL for the repo and putting it in my description, so that when you're in the Cloudformation view, would have a little blurb about, you know, what this thing is, and then a link to the repo from where it's deployed. And that kind of closes a loop for people who are troubleshooting. Because if you're in your AWS account and you're troubleshooting or you're trying to figure out where these things are coming from, it can be quite a journey to go backwards through your CI/CD pipeline to figure out how these things were actually created. So if we can go from the final, you know, the final stage on your pipeline all the way back to the beginning with one simple change, that saves a lot of time. And especially across a large organization where you have, you know, dozens or even hundreds of engineers trying to make sense of the mayhem that is production, you know. So I think it's just a really simple thing you can do to add a lot of value to your environment. So this will be the data store for Serverless Record Processor, the SRP. So even if you have this URL should work whether your repos are public or private, you know, whatever you got going on, you know, you should be able to put this in here. I put a pipe character in there. We're gonna see if Dynamo hates that or not. All right, I think we're ready to test. Let's see. So first I'm going to make sure that I have AWS credentials. Cool. Okay. There's my super secret information. We'll get rid of that because we don't want that to persist. Bear with me here while I remember. Actually, I'm not going to waste the brain power. Let's just figure out AWS CLI, Cloudformation. Validate template. I can never remember the option for passing a local file. There it is. Cool. All right. Doesn't autocomplete, which is really annoying. So I think that is valid. Question mark. Yeah, that's. I'm kind of surprised, so I'm going to go and very most definitely break this so that to make sure that it's actually validating properly. Okay, cool. So I did get it in the first try. We've all had those moments, right, where you sit and you write code for what feels like forever, and it just like flows out of you, and then you run it and it works for the first time, and then you say, "I don't believe you." I hope you've had those moments. They're really wonderful, and fleeting. So love that. Embrace them while you can. Okay, so here's where the make file that I like to put in these repos comes into play. I like to store commands like this. You know, it's a really simple thing, but it allows me to not have to waste is not the right term, but preserve brain power on these things. Path it properly. Here in the root, we should be able to just type in make validate, and it'll run the command for me. Okay, so we have that. So now we're going to write our create stack command. And these things can get pretty sophisticated as you work on them. Ooh, okay, we'll go through some of these because these are important. Okay, so we're going to use the CLI. We're going to tell Cloudformation to create a stack. And when these commands get really long, I start to put returns in here so that visually they're easy to read. Okay, this project is officially called the SRP, the Serverless Record Processor. So I'm just putting in, you know, the various parameters here. I think these are pretty self-explanatory. I don't know that I need to explain what the stack name or the template body parameters are to the command. But I think the rest of these start to get more important. So the parameters flag is super important because that's how we're going to pass information down into the execution. There's lots of important things that you'll pass as a these are Cloudformation stack parameters. These things will get important, and we'll go through those in a second here. So the rollback options are important if you know, if you want a stack, if you want really fine controls around the way your stacks deploy out, and maybe you want to hop in there and figure out like why is the deploy failing, or why is something happening in Cloudformation without it automatically rolling your changes back and kind of eliminating what it looks like. So at this point, I think Cloudformation exposes all of the information you need. Well, okay, let me rephrase that. I think historically you can walk through the events on a Cloudformation stack and figure out all the information just as well as if you didn't roll it back. Really wordy way of explaining. Like, I think you should be able to do your rollbacks and still get the information that helps you troubleshoot. Similarly, you know, you can go through, you know, all this stuff. So your rollback triggers would be if you it gives you a way to deploy your stack, let your stack kind of burn in this new configuration, and then it will listen for, you know, integer minutes here, and if it receives a notification from any of these ARNs, I believe these are SNS topics, it'll actually roll back. I'm not actually sure what these ARNs are. I'll have to dig into it. So this would be if you're doing like a blue-green deploys, or you're doing a more sophisticated deployment of your infrastructure. You know, you can deploy your stack out there, let it process traffic, let instances slowly roll over to it, and then when if any of your monitoring solutions determine that there's an issue, you know, notification can come in here and automatically trigger your stack to roll back. These are really sophisticated options in Cloudformation, and I don't think a lot of people utilize them, and maybe that's why they don't. I think Cloudformation is written from an operator's perspective, so that colors the way it feels to work with it. The timeout, ooh, fun. This is this is something I think people should really dig into when working with Cloudformation. So, like, if you don't have the default, let me rephrase that. So when you're creating a stack, if you don't set the timeout, there are some operations that can take a really long time before the, you know, you've got this like layers of operations happening in your account. So, you know, your stack is going to be like the top. It's like a process tree on your host. You know, you get your main process, and then you have all these forked processes out running, and then waiting for the callbacks back to the master, right? Same kind of thing, where you've got Cloudformation basically issuing CLI, or not CLI, API calls on your behalf to try and force the account into a certain, you know, perspective. That's what your template says. Like, I want these things to exist. And each one of those API calls or those operations has their own timeout. Cloudformation will wait X minutes for an EC2 instance to start. It'll wait however long for a Lambda function to be created, for Dynamo, blah 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 blah, all the way down your whole stack. So if you don't set this, you could be waiting a very long time if you have a big stack with a lot of resources that have a long timeout. So I highly recommend you pass the timeout flag in your calls. I generally would set it to, you know, if you're new with Cloudformation, you probably want it to be shorter, just because you're gonna have some fun waiting sometimes, not frequently. So we're gonna say just 30 minutes, because that's an arbitrary number I just came up with. It's long enough that some of the notorious resources will stabilize But if I have a bad configuration in my Dynamo file or something, I won't sit here for a day and wait for that thing to finish. And you might think a day is exaggerating, but it's really not. Like, there have been situations where trying to deploy out ECS or something has taken that long. I've gotten the message from AWS support to say, try again tomorrow. So timeout, super important, super duper important. Notification ARNs are another thing where you can send events, your stack, all the events that come out of your stack as resources are created as whatever happens. These events will be populated or pushed out to an SNS topic, and then you can have lambdas, you can have other things monitoring or subscribe to this topic, and maybe you can do some really interesting things with that. One thing I've done in the past is when creating one drawback that Cloudformation really has, and they might have fixed it, I haven't worked with it in a while, but it used to be when you would create a TLS certificate using the certificate manager, ACM, and you wanted, if you were making a cert and you wanted to use DNS records, if you do this in the console but by clicking through, it's super easy because you create a cert and then you say, I want to use DNS validation, and it says, okay, cool, here are the records, do you want us to add this to your Route 53? You can just from there hit the button, it adds it, and then it validates it all, boom, done. If you're creating that thing through Cloudformation, there wasn't any there wasn't an easy way to get those DNS records, which come out of in this event stream, to get those records into Route 53. So what I had done a long time ago was create an SNS topic and a route or a lambda function. So all stack events in the whole account, every time I would deploy a stack, I would configure this ARN in the command, and it would emit the events to that topic. And then that lambda function would basically just watch all those events, and when it saw a certificate create event, it would just create the records for you automatically. Maybe, I don't know if we'll get to that in this project or not, but maybe we might be able to see if Amazon has fixed that yet or not, because that was always a big pain in the butt. But we're not building a super sophisticated Cloudformation deploy here, so we don't need it. Capabilities is super important when doing Cloudformation deploys, because this is a flag that tells Cloudformation, yes, I want to create IAM resources. There's a lot of controls and safety measures built into Cloudformation, and this is one of those. This allows you, this is like this would be like a checkbox or a confirmation saying, yes, I am aware that I am creating resources that grant permissions, and basically I want to do that. We don't have any of these in this stack right now, but we will most certainly have them, so I am going to fill this out early and not have to deal with it next time. And there's a bunch of different capabilities in here. So there's capability IAM and named IAM. I don't understand why these are different. I'm sure there's probably some reason, but I haven't dug into it. It hasn't been invaluable to me. I name all of my resources because I like to use the principles of least privilege. everything has a name, everything has its own set of permissions, and they all, just doing capability IAM is never enough to get that thing actually deployed. So named is what I use. Yeah, see right here. If you have IAM resources with custom names, you must specify it. Well, then don't, I don't know why you would ever not name your resources. If you know, I'd love to hear it. Please tell me. Find me on Twitter or here in the comments. So you can constrain your resource types. Again, Cloudformation has a lot of safety, checks and valves in here. This would be if you wanted to constrain, say like, this function or this pipeline, this process can only create these resources, and then you enumerate them. We're not doing that here. It's a really cool idea though, if you're in an enterprise environment where you have lots of teams deploying stuff all day long, and you want to make sure that they don't deploy something they shouldn't. You can just constrain it to the given resources that you only want them to be able to deploy through their pipelines. As long as you control the Cloudformation commands here, you should be able to. It's just another layer of safety on opening up the gates to letting development teams deploy and manage their own resources. If we wanted a different role to deploy this, if we didn't want to use, right now we're using the role that's assigned to my Cloud9 instance, which is a super user role. This is a really, really bad practice, and I should be punished for this. What you should do is pass a role to this, and that's what this role ARN is there for. So you would, the user account or the permissions that I have assigned to this instance should have pretty limited access, and then everything in the account should be done through role assumption. And this would be another way where my user would tell Cloudformation to assume a role and do the deploy, and then I would just put a role ARN in here. And then here's another way to control your rollback. So when if your stack fails to deploy, you can set all of these options here. One nice thing is rephrase that. One thing that we did in a previous job that I really liked, but threw some people for a loop, was to automatically delete a failed stack on creation. And this was nice because it allowed the developers to iterate pretty quickly and not have to go into the account and delete a stack with the same name. That was the issue. Names would collide. So you'd have a stack there in a failed state, and then they'd try to do another deploy over the top of it, and it'd be red, it'd be broken. And then they'd have to reach out to the cloud team and have them delete that stack. It was just kind of a pain in the butt. Passing this delete flag on failure just cleans it up automatically. So if this thing fails, it just deletes it out of there. You won't have that namespace collision. Where that became an issue was putting this in the pipeline, and they would deploy out a bad stack. They would get confused because they wouldn't understand what happened, and that was because Cloudformation hides deleted stacks by default. So you can't, let's say You're working away. It's almost lunchtime, so you just hurry up, commit your changes, push them up, let your CI/CD process take over and deploy it out. You're going to come back after lunch and figure out what happened. You know, you got your coworkers breathing over your neck like they're ready to go. They're hungry. Like, let's go, let's go, let's go. Not saying this has ever happened to me many times. So you come back and then your stack is just not there. People would get really confused, and that was because the UI doesn't display that the deleted stacks by default. There's just a drop down you have to change in the Cloudformation interface, but we all know the AWS console is complete garbage. So you can't find those things. I think we might have to do a video in the future about setting these roles up properly. I want to get this project done. So here we are, we're already creating tech debt in a thing that doesn't exist because I want to get this thing done. But I'm already teaching people the bad ways. Oh, it's killing me. Yeah, so like these policy URLs, I'm not going to deal with any of that right now. Tags, always do tags. You get your request tokens. You got a bunch of other stuff here that I don't know that we need. You know, termination protection is kind of nice, but we're not going to use it. So our tags, let's figure out, what do we call this thing? Our project key or code is going to be the SRP. Tags. So you can do tags as this in this shorthand syntax, which is kind of nice. Key value with spaces. And you can do up to 50 tags. Cool. I frequently get a lot of compliments on the music that I play on this stream. So we're gonna give a big shout out to Harris Heller. He's the artist. He creates these songs for streamers, and then he promises he won't issue copyright strikes against it. That was just his new album that he just released of streaming music. If you're a streamer, if you make videos, if you do anything online, DMCA is serious business. Don't mess around. Okay, so we currently don't have any parameters on our stack. So we don't need to set it right now, but I want to at least put some put a placeholder in here. Oh, that's gross. Is that going to be any better? That's not great. Okay, so parameters are the way you take variables from your host level and you pass them down into a stack. There are lots of ways to get them in there. Oh, they're also a way to pull values from parameter store. AWS. Okay, let's see if we can get the whole name. So AWS System Manager Parameter Store. I think that's Systems Manager. Systems Manager Parameter Store. I don't know if you're not familiar with the Systems Manager family of products in AWS. They all have really, really long and painful names. Parameter Store is one of the important resources inside their services. It allows you to store regular information. It allows you to store parameters. I mean, it's pretty self-explanatory. You can do them as secure strings, which are basically encrypted secrets, or you can just do them as regular strings. I like using parameter store for a lot of... I do it for all of my secret management. I also do it for just general information. So usernames for... See, I got some really old resources in here. These are three years old. For a project that's long gone. But I like to use for database usernames. I also like to use it for information that stacks may consume. So if you want to kind of broadcast across your account, like, you know, this is the VPC information, or this is the, you know, the roles, or like whatever information you need to pull or consume as part of a Cloudformation stack. Parameter store is one of the places I like to do that. I also like to use Cloudformation exports, but have been bitten in the past with those. So I think there are... that might be another topic to cover, because there are real pitfalls in Cloudformation exports, because they create really tight coupling between the stack that's exporting a value and the stack that's importing it. So those are, yeah, that could definitely be a video. But we're talking about parameters, so you can pull them in to your stack from the CLI here, or you can define a parameter in your stack that pulls from the parameter store. So there are these other properties on here, like, you know, use previous value, resolve value. I generally don't use those. Those are just more sophisticated things that, I don't know, we don't really need. Okay, I'm over time. Let's see if we can make this thing deploy. So I've attempted to pass parameters to a stack that is not accepting them. So this is where I think, you know, Cloudformation is probably really frustrating for people. But also I think pushes really strong integrity. You know, like you've tried to define a parameter on a stack and the stack is not accepting it. This, to me, this is like you know, arguments of strongly typed languages versus loosely typed. But, you know, that might be... I'm just referencing here because... Oh wait, this is a type stack. This is for if you want to do nested stacks. There we go. I just wanted to make sure that it's just this easy. And it's not. Haha. Okay, we're not going to write this quite this long a description, but we are going to put, I duplicated that up. What did I call my parameter? Project key. So let's make that fit kind of the Cloudformation convention here. But the project key, it's going to be a type string. If you want the parameter to be optional, or maybe set to a default, you can specify that here. If I don't put a default value in my template and then fail to pass the parameter to this during the create option or the update command, it will fail. You can also specify this. Cool. We just created a Cloudformation stack. It was that easy. 50 minutes later. Maybe it's not that bad. You know, I did talk a lot. So here's the stack. I did that kind of fast. Let's go back. So you go into Cloudformation in your UI, in the console. Here's my stack. It's creating. Here's where I can see the URL. We can click through to it. You have a whole event stream on here with nice timestamps. Like, you know, these are the things that I really like about Cloudformation. It gives us a really strong history. We can see who did these things. There's just, again, operationally, there's a lot of things to really like about Cloudformation. You know, this part here was probably not so nice. You know, there's a lot of gotchas. It's kind of a pain in the butt to iterate through Cloudformation. But I still like when you're just learning AWS. You know, a lot of people will argue for Terraform. They'll say that, you know, Terraform is so much easier to write, easier to learn. And that's probably true. But the integrity or the process in which you deploy a stack and manage the stack, I think it's just a lot more sound if you don't have a team that helps you kind of design this process with Terraform. All right, so creating a Dynamo table will probably take a while. Let's go see. I did not prepare my account for everybody to see, so you're probably going to see all my secrets. Processed records right here. So if we have a table, it's created. We're probably just waiting on Cloudformation to realize that it's done. Cloudformation gives us this really nice, okay, so it's not nice, but a convenient way to show all of the resources that are part of a stack, part of an application, or however you're deploying it. And then quick links out. There it is. It's there. It's running. I don't know why. Oh, I'm sorry. I'm an idiot. It was created create complete was done a long time ago. I was still looking at these down here. Cool. Well, that was creating the Cloudformation stack. What do we always do when we're done? We make sure we commit. Cool, work is checked in. All right, so that was creating a Dynamo table through Cloudformation. Relatively painless, only because I've already felt all of the pain in the past. Next time I think we will, I don't know, I kind of want to keep tackling the back side of this, so the Dynamo table, the stream, the processor, and the bucket. Maybe I'll talk less and code more, or maybe we will hook up some CI/CD to this repo so that I don't have to keep issuing commands from my laptop, because this is a really bad practice. It's okay for personal projects, but for an enterprise I don't think it's all that great. Anyway, that's enough today. I have to get to do real work now. If you have any questions or comments, I'd love them in the comments, or message me. Find me on Twitter. You can find me on LinkedIn. I'm going to add cards or something to this. I haven't decided yet. It's all a work in progress, but aren't we all? All right, it's been great. Thanks, everybody. See ya.